What I mean by reshaping the data is that it may, number one, it may be clean, maybe not, so you need to clean it. But what is cleaning entail? Do you lose value, or do you kind of win value, or do you create bias by cleaning your data? So it's a process. Actually, from here to getting to the predictive modeling is really 60% of the work. It is, on average, 60% of the work, sometimes even more. Because you're trying to build a model and then you go back and you start over and you shape the data, you have wide data, you may try and make it a long data, or you take features, we call them features, the columns are features, and you may re-engineer them or merge them or understand the relationship between one feature and another that may be actually confounding the results. It may be even impacting significantly your results. So you want to make sure that there is independence between the predictors and the outcome when you're trying to predict. Okay. So until you get here, basically, this is very hard work. The problem is that universities don't teach you that. Online courses, they may give you, okay, how do you deal with missing values? But that's just one of the questions you face. Or when do you use it and how do you apply it and how do you analyze, let's say you have missing values. A lot of times I talk to graduates that just finished their latest from Kennesaw and others. It's like, oh yeah, well, we just impute the data. Why? Oh, well, that's the process. We just impute it. Or somebody would say, oh, well, we just take the average and apply the average.
Yeah.
Wow! That doesn't add value in any way, shape, or form by just doing that. Okay. So there are advanced tools and techniques for that. It deals with the sparsity of the data. And that's an area, for example, that's extremely specialized. There are people that spend their life 10, 20 years dealing with that sparsity of the data and how to solve that problem. So when somebody just said, oh, well, we just fill it in with averages or mean or, whatever, the maximum and minimum or some set value, you're introducing a whole new set of problems. Okay. So anyway, then we take you into the predictive tools and techniques that you may need. Just because you have data, it doesn't mean you can take it and throw it into a machine learning and up you go. The process of doing this is actually a research project. It really is a scientific research, because you try this and then you try that and that may work and they may not work, and you try different tools and techniques and then you compare results to each other. And you may actually end up with one model or ensemble of models that work in a specific configuration that will solve the problem for you. More than anything else, test validation. The testing and validation of your model is nowhere close to anything that you've done in IT. How many people do IT testing? Okay. Yeah? Okay. So what you will be doing in the testing of a model is completely different than anything that you have done. So you need to understand what data do you need in order to test it, and what the test performances, how do they compare to each other. You can't replicate. If you have good data, good variances in the data, chances are your predictive model, the data used in the testing and the data used in the training will produce different performances. So how do you interpret that? Do you just fail it? Is there a percentage at which you fail? No. There are ways to figure that out or accept it. But what that entails is not just a validation, but model evaluation in relation to what the business asks. Because just because you have a 86%, let's say, accuracy or performance in your model, you don't just throw it out, or you don't just accept it. Okay? It really goes back to the business to decide, because there are costs to that. The false positives and false negatives. There are costs to that, and what you need to do is you need to explain that to the business, because it means a solution, but it has drawbacks. An example, let's say retention, okay, or churning. So AT&T, it costs AT&T $500 to replace a subscriber. So when somebody, how many walked away from AT&T? Yeah, me too. I used to work for them, and I had to, I was a contractor there, and I had to use their services. But as soon as my contract was finished, I walked away. Why? Dissatisfaction. Now, let's think about this for a moment. So we're going to try and build a model to predict who will leave AT&T. So now think about the cost of this. AT&T, I think they had at the time something like 10 million subscribers and some of the services. So even if 1%, even if 1% leaves per month, that is significant, right? That's a lot of money. So if you build a model to predict who will leave, so let's think about this for a moment. Your model predicts accurately 86%. So what are the ratios of the false positives and the false negatives? And what are the costs? So Bo, I'm not picking on you, it's all right. Bo wants to leave AT&T, but we predicted him wrong that he's going to stay. And what's your name?
Ryan.
Ryan. And Ryan here, he wants to stay, but we predicted him he's going to leave. What are the costs of that? Now these are costs that were never accounted for. But everybody else here, we predicted you correctly. We predicted you're going to leave, you're going to stay, you're going to stay, you're going to stay, you're going to leave, and so on. Okay? So the model predicted everybody. Now, there is a saving. Instead of trying to go at everybody, AT&T would go to those that were predicted they are going to leave and make them an offer to stay. Okay. So even if they offer them, let's say, a service, free service for $200, it still is significant, because it would have cost them to replace these guys $500. Okay, so that's saving number one. Saving number two, all those that are going to stay, AT&T doesn't have to go to them. They can hit you with another service and maybe another bundling of a package or something like that, and make more money for you. Okay? But then those that were predicted wrong, what happened? He was predicted he's going to leave, but he was staying, and so Ryan got an offer that he was going to stay anyway, and he was happy to make the money. So that was a lost dollar value, as opposed to Bo was predicted he's not going to leave, but he left. So the cost is still $500. So you put into your financial model, and that's what that evaluation is all about. Is it worth it for the business to deploy your model and spend probably $10 million on deploying it? That's in addition to the research that you put into it to develop. Now, companies invest in all sorts of projects. And they know not every project is going to make them money, but they sure would like to know that you're going to make them money. So if you just took an online course and you try to figure out what are you going to do, and you started getting in here and you look at the data and think, holy moly, what am I going to do with this data? The online course didn't teach you that. It gave you the iris data set and the diamond data set, clean, clear as a whistle. Right. Oh. Clean, clear as a whistle, and you look at your data and it's nothing like it. So what do? Oh, okay, let me see. Let's buy some Tableau licenses. You buy Tableau licenses and you discover that, oh, well, shoot, Tableau doesn't tell you how to clean the data. Darn, so what do we do now? Let's get online and do some more. And companies spend sometimes 6 months to a year before they discover, oh boy, that is very expensive because you're paying people and you're putting them in a no-win situation. It really is the responsibility of the company to put you in a position that you can succeed. It's not just your responsibility to figure out how to succeed in the job that you've been asked to do. So then, what happened? What do you think happened?
We built a data lake.
Ah, okay. Here's another. And now we built the data lake and we're swimming in data. Oh, what do we do now? That's even a bigger sin. So what happened next? They start laying off people because they aren't making money. And you may be among those that you're going to send a package. So our mission at Anova Analytics is to help you and your company get there quickly and show the value and show you the process, the repeatable processes that you can do. Okay, so everybody now is logged in, so let's get to it. So what do you want to learn involved? Let's start with the RStudio. All right, so RStudio has a number of panels, so let's go over them quickly and talk about them. You'll notice that, let's go over the panels first, and then we get to the menu. Okay, so on the left top hand side, that's where you actually open code scripts or files, or you build new ones. Okay, and they are usually designated as R or RMD or some other, and we'll get to those a little bit later. But what this basically is, for example, this particular one is what we call Shiny app. Okay. Now, in the boot camp, we go in details, and that's what you will be building a model to run on Shiny. How many people heard of Shiny? Yeah, yeah. What it is, it's a portal that allows you to demonstrate your model, or actually even run it in a production. It has boundaries and limitations as a production tool, but it is part of a for corporations. It has also costs in addition. Is to run a server, a Shiny server, unless you're basically using the community, you may have to pay licensing for that. Regardless, the point is that it is a good way of building a model. So, but to build the model in Shiny is kind of an extra step. To build the model doesn't depend on Shiny. So Shiny, think of Shiny as kind of a wrapper to put in your model into that wrapper and deploy it. That's all. Okay? So this is one of the things that you will actually learn in the boot camp, but we're not going to cover it in details today because there isn't a lot of details. But if you were to do something else, let's say another classification model or something like that, that's what it looks like basically. You can see that comments, these are comments. Okay. And this is code. This is basically saying, this is one way of making use of a library. So we're loading the library MLBench, Caret, and DT. There are about 12,000 libraries in R, at least as of the end of last year. I think there is probably about 1,000 a year that gets added because there is a large community that contributes into that. Now, a provision here is that when a library is accepted into the CRAN or the R project, it really goes through a rigorous testing. Okay, so at least it's known it's a high quality, it meets certain quality. But there are a lot of libraries as well that are, the authors or the contributors of those libraries do not necessarily care to have it pass through that test. So, use your judgment, okay? Not that there is anything bad, but it's all open source. The majority of those libraries are open source. There are libraries about everything you can think, from economics to biotechnology to almost psychology, psychiatry, anything, weather, and so on, time series and so on. So there is a rich set of libraries that are available. Some of them have also demos and vignette. When you hear vignette, that's basically what it is. It is a document that explains to you, not just in technical details, but in examples how to. Now, every library that goes into the CRAN, usually it has help. It has a help menu built into that. And so we'll get to that in a minute. But what I want to say is that you can load as many here as you want, but it does get confusing eventually as to where your code is and so on. So use judgment. But in order to add one, you can just simply open more and open it, or you can actually add. And if you see here, there are a number of these, including C++, because there is an API, RCPP library that helps you with running C++ code within R, or call it from within R. Okay. Text files, Shiny apps, R Markdown. We will teach you in boot camp about these, but we'll touch on the R Markdown today. You're going to see a couple of examples today. This is like, how many people work with Notebook, Python Notebook? A little bit. Yeah, that's what it is like, the notebook, the Jupyter Notebook for Python. What it allows you to do is that it allows you to merge text, your code, and the results of your code all in one document. We're going to see that, how, and that's extremely useful. Remember what we were talking about, that research that you're doing? One of the things that you want to do is that you want to make your work reproducible, because you may even lose track what you did to it. So how do you do that? To go that standard documentation of IT is probably, How do you do that? In here, it makes it easy because you're merging your data, your code, and the outcome of your code, and your comments. So you can do your analysis and write it up, and then you run your script, and you look at the outcome, and then you analyze, and you comment, and you say, oh yeah, well, this shows that we're getting near that point that it's acceptable, or no, we're rejecting that thesis because blah. Your blah goes in here, and a year later or 10 years later, you go back and you look at that and say, oh yeah, that was the reason. Dumb of me, how did I not apply this new technique, which you may have learned 5 years later? Okay. But the point of it is that also there is a lot of rotation as well in the industry. So people jump from, go do 6 months here and a year there, and you move on and up, and some career paths are being made like crazy in this business. Okay, so you leave some work to somebody, and they come and look at what you did, and how do they figure out what you did? Okay. See, this was intended to be a scientific document, a scientific research. So to apply scrutiny to it, even to peer reviews, okay, you want to be able to show that. So that's what the R workdown is significant for. You can actually produce it fairly quickly and send it out to anybody as a HTML file. They can open it in their browser. They look at how you got your data, what you did to it, your thought process in doing this, and so on. So it's extremely helpful, and we rely on it actually for all the homework that we ask you to do. Okay, so there are scripts that you run, and there are tools that go with it as well that you can grab only one line and run, or there are shortcuts to that, and you'll find these shortcuts in here. So you want to run any number of formats, a region, previous, and so on. The other thing also that you will see is that you can also, there are codes that, just enter short code. So anyway, to build your code inside these files, and then you can save them just simply by going to the save. So if you notice here, these are dimmed. Okay. So if I go and change something here, what happened? Immediately it showed that, oh, you changed something, you want to save it. And all you have to do is just hit save. Okay? So, now, the other thing that you need to pay attention to is working directory. So now, let's go down to the lower part, and this is where, actually, this is your console. Okay. And the console is the results, the script that you run, and the results. So if I say get working directory, this tells me where my working directory is. Because I set up initially that the path already, that home starts here. Okay, now I could change, but the point I want to make here is that it always assumes if you start a new file or a new script that you want to do here, if you're starting a new script, it always assumes you're going to save it in that directory, in that working directory. But you can change that. And we'll get to that in a minute, where you can change it even without having to remember how to change it. Okay? So, but any script that you run here, so if I was to go back to this, the iris classification, okay? Now, see, if I was to run through these, and this is what happened. I ran the first, the second, and third. Now, let's watch this. And it says that the ML bench doesn't exist. So that means I didn't install it in the library. Okay? Now that's important, especially when you copy code from online. That is significant. What is the library and where do you find it? And sometimes it's not just a simple install, because if it is hosted on GitHub, it needs something else. If it is hosted on CRAN, great. You know, very simple. We'll get to it in a minute. But the other thing that you'll notice here also, that in order to have the caret library, it also depends on a couple of other libraries like the lattice. Okay. The last thing, the DT, okay, it has a warning that it says there is no package called DT in the library location. Library location, that's a preset place for me to put in my library. Okay. So what that tells me is that these two will not work. Okay? This will work. So now if I run any script that depends on these, that means I need to have that in the bench. Okay? We're good? Awesome. Okay, so let's go back up to the third panel. In the third panel, top right, okay, here there is environment and history. Now, let's go to history first. You will see, what did I just run? The three scripts that I just ran were these. Now, this is something, a practice that I do. You may want to apply it or not. Instead of trying to crowd my file here when I'm just experimenting with code, okay, I actually run them down here and see what they produce. And when I am ready to use some of them, because some would be nonsense, okay, I can go back here and take this and I can insert it. So let me position the cursor here. Unexpected crash. Okay, so it's restarting. Anyway, we're back on. Yeah, we probably are back on. Anyway, so if I highlight one, or let's pick this one since it didn't exist, I can push it to source. When I click on that, what did it do? It just placed it in my file. So you see that value of, you don't have to overkill your file or your script. You can test if you want, but that's my preference. You may choose to do something different. But going back and looking at that is useful in terms of diagnosing what you did, or grabbing some script that you ran earlier and you don't know it, and you can't remember it, or you can just grab a whole slew of them, okay, and just say, okay, I want all of these. And then push them exactly where you want. All you have to do is just position your cursor and put them in. And the source, there you go. Done. Okay? So these are simple things. The other thing that you do also here is that you can save. Now, it will ask you to save if you want to save the history. It will ask you to save when you exit. But you can work on something and without having to exit RStudio, you can get that history saved. And it will be saved as .history. It's an R file that the format is only known, it's serialized. So it's binary, and it can only be read by R. Okay, so you can actually go back and load that history if you choose to. And if we go and look at, yeah, we'll get to. No, we're there. Okay, so you see here in my working directory, there is R history file. This is, so if I can name it differently, but it would still be .R history. Now the default normally is no pre-text .history, that's the default. But if I want to save that as something else, I can do it and give it a different name. So let's call it Saturday. And save. And there's Saturday history. Okay? And then if you want to organize you can also delete all of that and start building a new history. Make sense? So this way you can slice and dice your work and what you did into these chunks. And they all have timestamps, so you can see that when they were modified last. And you'll be able to go back and load them up and look at them. Oh, what did I do there? Nice, huh? How many tools do you use that have that kind of? Pretty good. Okay. All right, the second part is environment. Now, environment is a kind of a complex concept. So let me see if I can explain that. When you're working in, what tools do you use to program? Java. Okay, so you use Eclipse? Okay, so you start a session in Eclipse, and it creates a set of resources, memory, blocks, files, and so on, right? And if you load up a particular library of Java, okay, it creates a space for it in memory or on file, and it builds hooks into it, right? So it expands that. So an environment is really a set of memory and resources and maybe files and maybe some other means, including graphics and output devices and so on, that they are together for that session. You may create a different session. We're not going to touch deep on that. But now, an environment is that set of allocated memory and resources and files and buffers and whatever that are needed, and they have their internal structure and priorities and hierarchy. Okay? So this is what that is. This is represented here as a global environment. And in the global environment, you can see all the variables that we created, either from past history, and we saved, and when we restart it, it goes back and loads it automatically. Or it can be something completely fresh. Okay, so we can wipe out that, okay, and completely start fresh. But in this case, for example, my look is a table, and if I click on it, I can see what's in it. It opens, so it opens it here, but this is my look, it says just a table. So this is a table, okay? Now, other things that exist in that environment are variables that I declared I may not be able to see. So this auth code doesn't exactly show here because it's not a table. Usually only tables or data tables that can be shown here. Otherwise, you can click on it or you can just say, okay, my look. Now, notice something here. If I want to take a look at it, oh, sorry, what was that? Auth. We wanted to look at auth. Sorry. Okay, so now notice what happened. It helps you at once you typed enough. Okay, so yeah, I want to see auth. And or other things that I can run on it but it's a Java object that was created, and it contains an authorization code. That's what it is. Okay, it's an authorization code to allow me access to another server online in the cloud. Okay, so so now back to this. So these are different things as well. The client ID, the client secret, etc. This was all done for the purpose of logging into a server and extracting some data. The data we extracted was actually this one, my look. How many people heard of Looker? Looker, L-O-O-K-E-R. Yep.
Oh, that event.
Ah, okay. Yeah, we had an event last month that they presented, and it was a great event. I think it was a little bit too technical for a lot of people. It's a good tool, but it was probably a lot more technical than we normally do. But sometimes we want to always present things that are easy for the average user to follow.
We also did record that presentation. It's on the Anova Analytics YouTube channel.
Yes.
So if you didn't see it and you're interested in looking at the actual Looker interface and seeing the demo, go to Anova Analytics YouTube channel. And,
Yeah.
Some of the video, it's not perfect, but you can definitely hear everything and you can see the screen well.
Yeah. So will today's session. So if you want to kind of go back, it will be available, right?
Yeah, about a week.
In about a week. So there you go. If you want to do a refresher in a week, bingo. All right. So in that environment, what you will find also, if you click on this, it will show you all the libraries that are currently in that were loaded either previously or in the current session, either from previous session, because as we explained, you can get off, close the RStudio, and it will ask you to save, and it will save if you wanted to, and if you don't want to save anything that you did, whatever was before the session, then will be retained. So when you go back and start over again, that is significant because sometimes you may do a lot of work and you forget, and then it crashes or something. You know. So what happened? Basically, then what happens is that you may have lost a lot of work. Okay? So save it regularly, save it under different names. Okay? In the packages here, so if I wanted to see what is in curve, how many people heard of curl, right? If you're a programmer, you should have heard of curl, because that's a method of calling remote data, right? Yeah. So in the curl package, notice what happened here now in the environment. What I'm looking at, these are all the functions inside curl. Okay? So multi-run, multi-list, multi-cancel, etc., i.e. proxy info, and so on. Curl download, escape, and so on. Okay? Now, let's hold off on that thought for a moment. What's important is that if you switch to this, then what it does, the priority of, or the hierarchy would change. In the normal global environment, when you're seeing up there global environment, it's the standard hierarchy of how it looks for things. But if you turn around and you click on the curl, now if you're looking for something, it's going to look inside the curl first, and it may not go back into that hierarchy of the global environment. It will restrict you to what you could be looking for. So if you're typing a command here, just as I was typing, it may not find auth. Okay? So if you start getting behaviors like that, look for, if you're still, especially if you're fooling around with this, okay? Look for that. You need to, for it to work properly, you need to always be in a global environment, okay? It's beyond the scope of what we do that we go into how to create your own environment and so on, but there are rules to that, and you can build your own separate environments and load them and change environments, but it could get dicey. So it's really very complex. Okay, now the other thing also that you will see here also is that you can also save and you can open environments. So if I go to save this environment, okay, so let's call it Saturday as well. And let's refresh. And what happened here? Saturday R data. R data is a very effective way for you to actually save data in the native format, in the R native format. Okay, that's the most common and most native format of data for R. Okay, it's R data. This is like, think of it as the binary, most effective, most efficient way of saving and storing data. And you can go back and load it just like we did with history. Okay, so you can save different versions of your environment, and in that environment, everything, the libraries, the variables, the functions, anything that you have had, okay, like this get data function. Okay. Yeah. Oh, by the way, yes, functions do open here. So get data. This shows what that function is. Okay. But all of that in the environment is saved in that R data. So you save it there, and your work is safe. Okay? You can go back and reload it or create different versions and so on, and you can overlap them as well. So I can go and clean this and create some other values, and then when I load that R data, Saturday R data, it comes on top. Now be careful, there might be conflicts sometime for same names. Okay, so you could create conflicts for yourself. Okay? So always when you do, be careful with the naming terminology. Build for yourself your own naming conventions and consistently follow them. You know that if you've done programming, right? Yeah. The favorite that everybody wants to use is data, to represent a data set or a table. Bad. horrible, terrible, okay? The only place I would use data is that if I am calling a data set that exists, that's just the most common way. Let me see where would be an example of that. Yeah, here. Data iris, this is the only form that I would stay with it. But that's because the iris data is built into a library inside R. So to call a data set that exists, that's the format. But if you want to upload a file or read a file or something or generate your own, do not use data. Because what happened, it may conflict a lot of times, sometimes, because this is a reserved term. This is a reserved term in some of the functions that you may be using or calling data. You need to put data equal something. So now what happens if you're using data with some precious data set that you saved and you've built over a long time, and you trimmed and you refined, and then it gets wiped out. Okay? Gone. You can't recover it. Okay? Unless you saved it in our data somewhere and you kept track of where. You can always look to 2, 3, 4 different versions of it. But the point is that that is significant. Okay? All right. The other thing that from here also you can import. And these are the easiest way to actually not to worry about how do I import a CSV file or an Excel file or SAS or SPSS or Stata. Very easy. You don't need to remember the code. It builds the code for you, and it's a user interactive, so it allows you to look for, okay, so there you go. So now we go and browse, and I don't have anything here. No, JSON, and so maybe something here. No. Anyway, I think there might be something here. So data sets. Okay. All right. So we want to bring in the income. It gives you a preview. Now, let's look at this as well here. It gives you the option if you want to skip the first row as names, yes. Trim spaces, yes. Open the data viewer. You know, this is to look at it afterwards or not. Is it comma separated? Yes, because it looks nicely formatted. In here, you can actually. So if this is integer, and I don't want it. What is this? It looks like is that a zip code? You know, maybe it's not actually an integer. Let's say it is a text. So I can change that to a character. Okay, so it retrieves the data and presents it as characters. Okay, so it makes it easy for you to do all of this, and then when you're ready, yeah, it's still rereading that and converting it, you know, from integers. It's taking longer than usual, probably. Anyway, we don't have to wait for it. We can cancel this, but the point is that you can do that. And when you're ready to import it, you're comfortable with that assignment of the field, you're ready to import, you import it. And look at that. We've got it all here. Okay, so there is income. You can actually rename that as hours. I could have changed that to what did I want to name it coming in. The file was called income, but I don't have to keep the name of the data table as income. Okay? All right, so this is, the same thing, like you can save and open another one, and you can clear, completely wipe out everything in the environment. All right, so down to the last piece, and then we will take a break. We'll take a quick break. Anybody wants to go health break, coffee, grab some more of the goodies there, okay? And then we'll start fairly quickly after that with R. All right? Okay, so now, down at the bottom here, there are a number of things. File or files, that's where your normally working directory that you can change where that is pointing to at any one point. Okay, so right now I could have it pointing there or there or somewhere else, okay? It doesn't have to. Now here is the other thing that, remember we were talking about switching working directory. This is where you can do this. So you can point it to wherever you want it to, and in here you can say set as working directory. Okay? So then you can set it as your working directory, or you want to, you can go to the working directory that was set beforehand. So if I click on go to working directory, it took me to my directory and ours. Okay? Couple of other things. You can actually pinpoint to particular files and do something with them, such as rename, delete. You can do upload or create new folders. And there are a couple of other things here that we didn't talk about, and that is copy or move. Okay? So you can select, just like I did here, and then copy. And I can give it another name. Test. And it created the test. That's okay? All right. Plots. Anything that I plot in here will show up here. So let's see quickly if we... Anyway, when you plot something, it will generate it will generate a graph, and in here you can basically, if you want to have a better definition of the graph, you can expand that. Okay, so you can expand it. And also, once you create a couple of graphs, you can navigate back and forth. And you can export or you can zoom. When you zoom, it generates a window, independent window, for the plot that you can resize and create dimensions. We'll see that a little later, anyway, once we start going around the R. The other thing that you can do here is that if you want to export, you can actually save it in different dimensions. So you can choose the dimensions you want to save it in, as PDF or as an image. Packages. See, this shows you all the packages that are there. And if you see one checked, like that, it means it's already included in the current environment. Okay? And one way to uncheck it or check it is to do this. And you can see here that we detach from reader, or we attach it again, and it loaded it. Okay? So that's one way of quickly doing that. Now you have to remember also, if in your text you do a lot of these libraries from here, they will not be captured up here in your document, in your program. So you have to use judgment, and that's where I use the history to go back and put it back in. Okay? Because if you build your your model and you save it, and then you clear your environment, so the libraries are no longer there, you go back to your script and you try to run it, and oops, it doesn't run, right? It would say, oh, this code, I don't know what that is. There is an error, or some cryptic error that you try and figure out. So be careful with that. The other thing that you can do is that also you can update. And when you update, it will show you which ones are ready for update. Now be careful. In this environment, do not do updates. Please don't. And I'll explain why. Because we have a server library that is in the global environment. It's global to everyone. Okay. Now, you can install a library if you want, but it will install it in your own environment only, and not in your own environment. In your own library, for you as a user, it will not change the global environment where we have it. So if you go and build your code on the basis of that environment, based on that library, even if it is a different version, okay, and you say, oh, I'm having trouble with my code, can you help me? And then I try to run it, let's say in my user, what happened? I don't know what library you had, or what version, okay? So that is important. Okay. Now, if you do load a library, be careful, you're taking your own risk, okay? So you can get in trouble. So make use of the libraries that we have, don't try and... Now, this is a private, this is my own private package or library that I loaded just to make a point, and that exists in the files in R. There is a designated private library for me, so if I go into it, I'll find RDR, read R, okay? So, but it isn't part of the global library that we have. Now we could add it there, but as of today it's not. Okay, we'll add it later. Okay, so the other thing that you can do with packages also is that you can install. So you can go and pick up, let's say, XLS, and it will give you like XLS jars or something like that. Now, XLSX and XLSX jar, okay, you normally go together. If you load one, because it is dependent on the jars, it will load it with. Okay? Now, if you're doing that on your own system at home, there's no problem because I would presume that you've set it up properly. Okay. We're good? Okay, help. This is your best buddy. And I mean your best buddy. This is where you're going to find out about things. So now, if I want to look for there is no JSO or anything that starts with JSO. So let's say I want to look for Java import. Now, it tells me which part of the library it belongs to. That is a function that is part of the R Java library. Now remember something. It will not find you something in a library you didn't include. So if you didn't include that library and you're looking for something in that library that's not included, it will not know. Okay? So if you want to look for a particular function, what do? That you go looking for 12,000 libraries? Any suggestions? What do? Google. Your next best buddy is Google. So you go and say, let's say, Java import or import in R. And it's going to give you a couple of thousand, maybe a couple of 100,000. Okay? You're going to be spending actually on Google more time than you probably at the beginning spend inside R. But that's okay, because you will learn. It will give you which library it is, if there are PDFs that exist, you know, where, what, how many libraries would have this import or something. Okay? So, this is your best buddy, but this is, like I said, it's limited to what libraries are in the environment and the base R. The base R has a rich set of built-in libraries right off the bat. But the rest, basically, you kind of have to find the library. But this is part of what we teach you, is that in order to do the job that you need to complete, what are the libraries that are going to be most useful to you. So in the boot camp, actually, we spend a lot of time on these libraries, individual libraries, and how to use them. Okay? Because no one's going to teach you that. You'll find a lot of information, and you'll find that, oh yeah, okay, this is how I use this function. Okay, I need variable A, variable B, or argument A, B, C, D, and what these arguments are, but what does that mean? When do I use it? Why would I want to use it? How? And when I use it, is the outcome good or not? Do I accept? Because what are you doing most of the time with data science? You are researching, right? It's a research project. So basically you're always doing 2, 3, 4, 5 different things, and you're comparing. Is it right? How do you know? We teach you that. Okay? All right, break.